Okay, what would you like to see from the homework, kids? What would you like to see?
Exercise
9?
9? Yeah. Well, no, you gave us that at the end of class. You gave us exercise 9 to do. Like,
Oh, is this on here? Let's see here.
should be. Yeah, that one.
This one right here? Yeah, hit the lights, please. Yeah. So it says, then sketch the graph of h. So you're supposed to sketch that graph. So for sketching that graph, what do you need to do in order to, what do you need to construct? We began constructing it. Points. You're constructing a, what are you constructing? You're constructing a table. So you need to construct the table and then connect the dots. I'm not going to do it out. You construct the table and then you connect the dots. Construct the table and connect the dots. Yes?
The value for y was wrong.
Oh, did we get it wrong?
Because you have to cover, casting.
Well, let's take a look. It's h of 0.5 is going to be f of g. So you need g of 0.5. G of 0.5 is 0.75, and f of 0.75 is about... Oh, is it 1? No, it's not. H of 0.5 is the same thing as f of g of 0.5. Okay, so do you agree with g of 0.5 is 3/4? Is this correct? I think so. And then, oh, I see. We read it wrong. So it's no, it's f of 3/4. F of 3/4 is right about here. That's f of 3/4. And f of 3/4, that's -1, -2, -3, and
Like 1 block is 0.5.
Oh, 1 block is 0.5. Did everybody see that there? Oh, yeah, yeah. So this is -1, so this is -1.5, so it's like -1.7 something. Yeah, -1.7. Good call, yeah. Good, the scale was wrong. You're very good. So you make the table, everybody. You make the table, and then you connect the dots. Make the table, connect the dots. I'm not going to do it out. Okay. Anything from last night's problem set? Anything from last night's problem set? Any? 29? 29, sure. We can do 29, absolutely. So we're supposed to graph f plus g, right? So what's the best way to go about doing this? What's the best way to do this? Make a table. So we have x, we have the value of f, and we have the value of g. So let's make a simple table here. When x, so we have, let's do 0. How about we do 0, 3, and 6 to begin with. At 0, what's f? 2, what's g? 2. So what's f plus g? 4. At 3, what's f? At 3, what's f? What's g? About what? 2.8. That looks good. Add them together, what do you get? 6, what do you get? 0. And? So if you plot these points here, you know it's going to go to 4. And then at 3, it's what? 3.8. And then here it's 0. It might be good to plot a couple more points. Let's plot the point 1 and see what that is. If you plug in 1, what's f? About what? Let's say 1 point, a little bit more than 1.5. 1 point what? Let's do 1.7, sure. And what's g at that point? 2.8. Add them together, what do you get? 4.5. I like adding that in because you get 4.5, so right about here. So what is this thing going to look like? There's your curve. You are adding to g this distance, and then you're adding less and less. So by the time you get to 0, they meet because you're not adding anything to it. Does that make sense, everybody? You're adding the functions together. Are you changing the x values? Are you changing the x values? No, you're not. Okay. What else? What else from the homework?
36.
Yes.
36? We had an emphatic agreement with 36. 36? Oh, that's an exciting one. 36. You just wanted f of g, g of f of f, and g of g? What, you don't like doing that?
No.
Well, it's only 4. Yeah, oh yeah, you know, you gotta practice. It takes time. Okay. So which one do you want to help with? I'm not gonna do all 4 of them.
The just
Pick one. Which one? We are not going to do them all. Which one do you want to do? G of G? So that means, so it's G O G, which is G of X. Right? So what are you plugging in? You're doing 5 times G of X squared plus 3 times G of X plus 2. So that's 5 times 5x squared plus 3x plus 2 squared plus 3 times 5x squared plus 3x plus 2 plus... Done. All done. You don't really have to multiply that out. That's fine. You can multiply it if you really want to and simplify it into a quartic if you really want to. Not really important. I want to see, if I see this, you have communicated to me that you understand what we were trying to do with this topic.
so
The domain? What's the domain of this? Yep. There's no division, there's no roots. Domain's all real numbers. You can plug anything you want into it.
if you were doing like G of F,
G of F?
you
So G of F of X. So you do 5 times F of X squared plus 3 times F of X plus 2. So what's F of X? 1 minus 3x squared plus 3 times 1 minus 3x. This is simple enough that if you really wanted to, sorry, you could multiply this out. That was nice. I'm glad that's on tape. I continue teaching while sneezing. It's like a badge. It's kind of like a Boy Scout badge. The teacher badges that the teachers don't know about. Every once in a while, a student gets up and just gives us a gold star, like on our cheek or something. That'd be good. So yes, I that makes my day. I am so dedicated to my craft that I continue teaching while sneezing repeatedly. Okay. Any other burning questions from the homework? Anything else? You haven't. 40. What about 40? Oh, 40. Something different. What's different about 40?
just like that there's 3.
Did I give you 40?
Yeah. No, yeah. I thought you gave 35 to yeah, 40.
40. Okay. Nice. Okay. It's like, yeah, I did it. Uh-huh. Sure. So, what's the only difference now? What do you have to find? You're finding f of g of h, right? F of g of h. Now, how many compositions can you do if you wanted to do? How many can you do? Is there a limit to how many compositions you can make? Could I do f of 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 g of g of g of g of g of g of x? If you wanted to, right? Could you? Yeah. What does this mean? What are you plugging into what here? What are you first plugging into what?
H of G.
H into g, and then what you get into... So this means f of g of h, right? But that means f of g of h of x. So what do you have to do first? H into g. So that's going to be cosine of h of x. I'm just doing it out. You don't have to, when you do this out, you don't have to do it every single one of these steps. I like to do it out just so I can communicate to you what's going on. Feel free to do this out, though. That's fine. So then you have f of cosine of square root of x plus 3, right? And now what do you have? 2 over cosine root x plus 3 plus 1. So we've done it that much. That actually was relatively straightforward. What's next? What do we have to find? Domain. It asks you to find the domain, doesn't it? It doesn't? Okay, well, let's find the domain. What are 2 things? We have to watch out for 2 things. What do we... Yeah, negative radicand. So we know that x plus 3 has to be greater than or equal to 0. It can equal 0, right? Could it? Well, can it equal 0? Sure. So we know that x has to be greater than or equal to negative 3. But what else? And what else has to be true? And what? What can't be 0? So this can't be what? Well, that can't be 0, right? Exactly. But then you go one. What you said is the next step. That's absolutely correct. You know that cosine of root x plus 3 can't be what? We want to know when it equals 0 because we want to know what it can't be. How do you go about solving something like that? How do you solve cosine of the square root of x plus 3 equals negative 1? If anybody says square it, just don't. I'm just cutting you off right there. Please, no. What do you do? What? Inverse what? Yeah. So you know cosine inverse of negative 1 is equal to plus 3. And if we really wanted to, let's just boot this up. Second cosine inverse of negative 1 is... Yeah, the cosine of what is negative 1? Yeah, so that's when you go to, oh, I should have seen that coming. Oh my god. So pi is equal to this, right? So now what can you do? Now you can square it. So x, that's cool. You never really see pi squared. So what does x equal? Pi squared, what? Minus 3. Approximately what is pi squared minus 3? A little more than 6, right? So both of these things have to be true. This has to be true, and x cannot be pi squared minus 3. This is a great question. So what's the domain of this function? X such that x is greater than or equal to negative 3, and what? Such that, yeah, x not equal to pi squared minus 3. That's a great question. I like it when it works out that way. It's kind of cool. We could verify this graphically if we wanted to, and hopefully it would match, but we're not going to do that right now. Good question. I like that one. Just remember that. Okay. Moving on. Anything else from the homework you want to discuss? Anything else? Anything else? You feel pretty good about the rest?
It's all the same.
It's pretty the same. I know. I'm trying to beat this into you. Apparently some people like to beat up their paper. That's good. You remind me of a student I had once that no matter what the assignment was, no matter what the length, the paper always came back in the exact same condition. Slightly crumpled, with some holes in it. It was like a 20 minutes or like 3 days. Same thing. It was amazing.